Okay, so rational zero test is probably new to most of you. So what is it saying? It's saying if there's some polynomial, this is fancy math speak for some polynomial, has integer coefficients, then every rational zero, okay, what is a rational zero? Let me just tell you what this is. It means you have a factor that looks like this, and P and Q are integers. Okay, that means it's a rational zero, as opposed to this will be an irrational zero. Got it? Hopefully. Must have the form x equals p over q. This is nothing new. Okay, so this part is new. If it's rational, it has to have the form p over q. But the point is, the numerator has to be a factor of this guy, and the denominator has to be a factor of this guy. For example, we're saying if we have f equals 3x cubed plus 7x squared minus 2x plus 1, we do not know, well, it's a cubic, so it has one, it has at least one real zero, but what it's saying is if it has a rational zero, it's not even guaranteeing that it has a rational zero, but if it has a rational zero, then the numerator has to be 1, and the denominator has to be either 1 or 3. So it could be 1 over 1, 1 over 3, minus 1 over 1, or minus 1 over 3. This does not tell us whether or not any of those are going to work. What it does tell us is if we're using synthetic division, or sorry, we're using the same things we used in the most recent chapters, which were doing polynomial division, then we only have to try those 4 possibilities, because if they all fail, then there's no point, excuse me, there's no point in trying anything else, because those are the only possibilities that could potentially work, and if they don't work, we can just go home and forget about it. Okay, so let's see what this means. So first of all, I'm not going to make you do a question that's quite that complicated. I would not. So for example, I consider this to be the first in a 2-part of a more complicated exercise. The more complicated exercise is to give the student this, this, for example, f equals x cubed plus 8, and say, please factor that. That's the complicated exercise. But what I would give you is the first half of that exercise, which is simply list all the potential rational roots for this polynomial. And then the second stage, which I wouldn't ask you to do, is to say, find out which of these is actually going to divide the polynomial. But you see, that's really labor intensive. So what I would do instead is I would ask you a simpler question on the exam. I'd say, divide this polynomial by x minus 1 or x minus 8 or something like that. So I would have you demonstrate your skill of polynomial division as a separate exercise from testing this concept. Okay, but I want you to understand, in theory, it's part of a longer problem. Okay, hopefully that was clear. So let's say factor f. So if we can factor it using rational numbers, so it's possible we could factor it using some other thing. In fact, it's actually guaranteed that it has 3 roots. They may be duplicate, they may be irrational, we don't know, but it's guaranteed. There's a fundamental theorem of algebra that says because this is a polynomial of degree 3, we're guaranteed 3 roots. So it's not whether it can be factored, but if we can factor it using rational values, then it has to be one of the following. So let's see, what did the theorem say? We want to know all the factors of this guy. Here's all the factors of that guy. And there's a 1 in front here, so there's only a factor of 1. And so what does the theorem say? Which guys go in the numerator and which guys go in the denominator? Alright, factors of the tail go in the numerator, and factors of the front of the polynomial go in the denominator. It always seems backwards to me. I always think it should be the other way around, But, you know, this is the kind of thing, you just write this little doohickey on your 3x5 card so you don't forget which way it goes. Okay, so the possibilities are plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. This comes from here, both pluses and minuses, but all over 1. So we don't have to write these, but they could be over plus and minus 1, but we already included the plus and minuses. So this is our entire list of possible rational values, and it turns out, so this is when you would use Wolfram or something to help you. F of minus 2 equals 0 works, okay? So the way I could word this question, if I did want to do this, I could say, given this function, tell me all the possible rational values according to the theorem that it could possibly have. What are the possible rational zeros? And you would give me this list of 8 values. Then I could say, by the way, -2 is a rational zero of this function. Now go ahead and divide it. And then you could separately say, oh, okay, x cubed plus 0x squared plus 0x plus 8, and then remember it's x plus 2 that you're dividing, and then you'd work it out, okay? So I wouldn't ask you to go through each of these 8 possibilities on an exam. That's just ludicrous. Okay, so let me do another one. Here's a question. List all possible rational roots for f is x squared minus 7. So what does the theorem say to do? It says, all right, what are all the factors here? Plus and minus 1, plus and minus 7. And again, this is just a coefficient of 1. So the possible roots are plus and minus 1 and plus and minus 7. And do any of them work? Well, you could actually just see with your eyeballs. This is actually easy. I can test all these, and none of them work, right? What's f of 1? Well, it's -6, same as -1. What about 7? 49 minus 7 is 42. Okay, so none of these actually work. The theorem did not say that. First of all, it didn't even promise we had a root. This is a parabola, so maybe parabola doesn't even have a root. But in this case, the parabola does have 2 roots. You know where they are because it's a parabola. It makes it really easy. You know where those roots are. So clearly, this theorem has limited value. It is a very, very small, limited value for you. All it does is it tells you that if the roots are rational, they have to be one of these values. But the roots don't happen to be rational. Okay. Here's another one. Okay, why don't you try? I'll tell you when to pause. List all possible rational zeros, or you could see it written as rational roots, and test them all. Obviously, it's an easy function, and so you can test it. I'll tell you, you pause now. Okay, so what you want to do is all the roots on this guy is just plus and minus 1, and then the coefficients on that guy are just 1. So this is just really easy. It's just plus 1 minus 1. So f of 1 is 1 plus 1 plus 1, which is 3, so it fails. So there's no root there. And f of minus 1 is minus 1. Minus 1 plus 1 is equal to minus 1, so that fails too. Great. Okay, so it has no rational zeros. So f has no rational zeros. Does it have any zeros? Well, I'm going to just do this little aside. If it were just x cubed plus x, then I would say, let's see, if it were just x cubed plus x, it would look like that. So if in that case, you'd have a root at 0 and no other roots, so you'd have this funny looking thing. Let's see, something like that. I don't know. That's not exactly the way it would look, but something like that. And then, so if you lift this thing up, then it's going to do something like that. So there's going to be some kind of negative root. But you can just ask Wolfram alpha to figure out what that is. I wouldn't do it by hand. That's as much as I would do by hand. But I don't expect you to do this. I'm just showing you what I would do. So yes, it has a root. It has a real root, but it doesn't have any rational zeros. Okay, I'll give you another problem, and I'll tell you when to pause again. You try list the possible rational roots of. Okay, now you want to pause. Okay, hopefully you got the following answer. This would be plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. Those are all the things that the 8 can factor into, and there's just a 1 here. So the numerator, I'm sorry, the denominator is irrelevant. So you just get this whole list. I think all of our examples so far, I've let that coefficient be 1. We'll have to do one that's a little more interesting. Okay, now find a 0 of f. Okay, so we can go ahead and do this. We can start hitting this. Now this would be okay as a homework. This is totally okay as a homework, but it's annoying as an exam question. So try f of 1, try f of minus 1, then you're going to try f of 2 and f of minus 2, and so on and so forth. So let's see. This is going to be 1 minus 5 plus 2 plus 8 is not equal to 0, so we are unhappy. But then what about negative 1? Does it work? We can get negative 1 minus 5 minus 2 plus 8 is equal to 0. So we found a root. And this is great because since this is a cubic, cubics, all we need to find is one root. Why? Because then we'll use the quadratic formula to find the rest of them. So let's go ahead and divide this since this is begging to be done. So this is a quick little review of what we did in the last video. Okay, so if you want, you can pause and you can practice this. All right. Let's see, we have x squared, so it's x cubed plus x squared, subtract this out. All right, how many times does x go into? Minus 6x squared, that would be minus 6. Don't forget that's a plus. Yay, and it comes out even. It has to. But here's the deal. X squared minus 6x plus 8. You can use the quadratic formula if you want, or you can simply factor. And voila, we have x equals 2 and 4. So we actually have 3 rational roots. We have negative 1. So this is our whole set, 2, 4, and negative 1. So in our original set, out of the 8 possible rational roots, 3 of them were actually roots of our problem. Okay, I promised you one last example, which is not in the notes, but I'm just going to make something up. List all possible, sorry, sloppy, you know what I'm going to write. 0, okay. 6x cubed plus 2x squared minus 7x plus, I'm just going to make it something prime and ugly. Alright, how do you do this? Well, this can just be plus or minus 1, plus or minus 11. Those are the only factors of 11. But 6 could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are the possibilities. So you have to divide by all this mess. It could be plus or minus 1 over 1. Or plus or minus 11 over 1. Then you can go plus or minus 1 over 2, plus or minus 1 over 11. Plus or, no, I did this backwards. Sorry. Plus or minus 1 over 2. Plus or minus 11 over 2. There we go. See, these guys go in the top. Plus or minus 1, plus or minus 11. This gets really nasty, doesn't it? And then we did the 2s. We got to do the 3s. And we got to do the 6s. Okay, I think we got them all now. Okay? So I'm not going to give you that example. I just wanted you to see how it works. And that bell is to tell me to let my students out of class. Isn't that funny? My alarms still go off. They don't know that it's a snow day. Okay, so we're not going to have to study that. Okay, but I just wanted you to see it once. Okay, have a good snow day.